before we begin, Laimonas and Mikk asked me to maybe do a small poll just for us to understand better the level of experience we have now in this event, so that they could adjust their presentations accordingly. So I'll just start a poll, and just please choose the option that reflects you best, and then I'll share the answers with everybody, so you could see like what do we have in the room. Okay, I see votes coming in. There are 55 people join now, and we have 30 votes already. So let's give some more time for everybody to present their views. Okay, I see that the votes have stopped, but yeah, it should reflect more or less the biggest part. Okay, and I'll be sharing the results. Hopefully you see them as well. So Laimonas, Mikk, if you see them, so we have about half of people that are like mid-level experts. I have some experience with AWS. We have 20% that are pros, and 1/3 is like few or very zero experience. So hopefully that will help you in presenting the slides that you have today. Okay, so that's it from my side, I guess, for now. Laimonas, are you ready to take over with your part?
I think I am.
Okay, will you be sharing the video from your side?
Yes, let me share it, and let me know, can you see it?
Yeah, I can see your screen.
Okay, and the most importantly, can you hear me clearly?
I can. Maybe somebody from the chat will also write. Yeah, I see answers that people hear you good as well.
Okay, awesome. Then I think we can start. All right, so hello everyone. Thank you for coming. I hope everyone is having a good time despite the quarantine situation. Today I'm going to give you a simple presentation on how you should deploy a database to AWS and how you should manage the database credentials. So a few notes about me. I currently work closely with two companies. I work with Biomapas, which operates in a life science industry, and iDenfy, which operates in identity verification industry. I have roughly 3 to 4 years of AWS experience. I have played with nearly every resource that is available on AWS. So for example, from serverless Lambdas and Fargates to Kinesis streams and machine learning services. I have around 8 years of programming experience, mainly Python with Django and C# with .NET Core. And most importantly, with the help of iDenfy and iDenfy colleagues, we have published around 20 Python packages that are available on PyPy and are AWS infrastructure based. So you can come anytime, grab what you need and start using it. More on that a little bit later. So for the agenda, I will start with don'ts. I will show you how not to deploy a database and not so great ways of storing DB credentials. After that, I will show you, which is, in my opinion, probably the best way of DB deployment and credentials management. So let's talk about DB deployment. But before that, for the sake of simplicity, I will assume we want to deploy a MySQL database. However, this is perfectly fine if you are using a different one, for example, DynamoDB. As long as it's AWS managed, it will work just fine. So we have here a user interface, which is prompted to you when you go to RDS and click create a new database. So you have just to put some configuration to it. And let's talk about the default subnet group. For short, don't use it. Don't use the default one. Create one by yourself. Why is that important? When you create an AWS account, by default, you get a default VPC configured with default subnets, which are public. And you don't want to deploy your DB to a public subnet. By the way, as I see that there are quite a lot of new guys to AWS, so a public subnet is, you can imagine, it is a kind of a space where you deploy your resources, and those resources can be accessed from outer internet. This is a public subnet. A private would be that outer internet cannot reach you. So with that said, you want to deploy your DB to a private, or more preferably an isolated subnet. And an isolated subnet has no way of communicating with outer internet. Well, there are some exceptions, but mostly it holds true. And this is where you want to deploy your database, an isolated subnet. Secondly, I know that sometimes it is super tempting to make the database publicly accessible. The database then can be reached by public Lambda functions, and most importantly, your computer. However, this is a huge anti-pattern, and you should not do that. A public database will have a public IP address, which of course can be attacked, and where a private one will not. Next, don't simply use the default security group. For those who don't know what a security group is, it is basically a set of rules telling what traffic can go in or out the specified resource. So you can restrict ports, you can restrict IP addresses, you can restrict destinations, and you can restrict sources. So don't simply use the default one that is currently provided you in the user interface. You can increase the overall security of your database by creating actually 2 security groups and chaining them together. And I will explain more deeply what I mean by that in later sections. So don't use the default one, create 2. Next. It is generally a bad practice to use default KMS keys provided by AWS. And for those who don't know what KMS is, KMS stands for Key Management System. And KMS keys are encryption keys that are used to encrypt or decrypt various AWS-based resources for the increased security and sometimes policy compliance. So you should definitely create your own custom master key, which for short sounds like KMS CNK. And by doing so, you get more power over controlling who gets access to it and who doesn't. And you know what? User interfaces are awesome for presentations, demos, and learning. However, there are way better ways how you can and should manage and provision a production-ready infrastructure. So let's go to the second part. We have, let's say, deployed a database. How and where are we going to store its credentials? Well, the simplest way is to provide it directly in the source like that. But I mean, you must be crazy to do that. Well, we can move credentials to constants as it signifies that they don't change. However, this does not solve the problem. Most commonly used ways, so the most commonly used way is storing credentials in an environment. Either it is an operating system environment, Lambda environment, or ECS environment. This way, of course, you can exclude your credentials from the source code itself and make the code more reusable. Now, the question is, how are you going to set the environment itself? For some time, I personally have used a separate file, which I called a .env, and I would include, modify, and manage it in the already deployed project. I would definitely not include that .env file to my source code repository by ignoring it in the git ignore file. And this kind of works. This is kind of secure. However, this is a Stone Age solution and a very impractical one. Let's say once you have changed the endpoint or password of some resource, now you have to log into every deployed instance and modify its .env file. It is ridiculous, and it is not how we want to do things in AWS. And actually, the same logic applies to other environments, not only operating system environments. A Lambda, you can see here a Lambda environment here, and so the statement holds true that it is not the best way of doing things. All right, so we have talked about that, and let's talk the real business. And let's create a great database deployment, and let's create a credentials management infrastructure. So the very first thing, as I mentioned previously, do not use user interface. There is a wonderful concept called infrastructure as a code. Basically, that means that you create, manage, provision your infrastructure by writing a programming code. CloudFormation, however, I would say hardly fits to that concept, because you need to provide JSON or YAML templates, which are honestly horrible to manage. Therefore, in the industry, we can see some wrappers or alternatives emerge. A troposphere is a great Python library that translates Python objects to CloudFormation-based templates. So you no longer have to deal with those JSON or YAML files. The second solution is a Terraform tool, which is a complete alternative to CloudFormation itself. It simply executes a set of API calls on a given machine. It has its own programming language, which I personally find it, well, a JSON on steroids, I guess. So personally, I don't like Troposphere nor Terraform because they are third-party solutions and they come with their own disadvantages. Thankfully, AWS has released an amazing tool called AWS CDK, and CDK stands for Cloud Development Kit. And honestly, I cannot emphasize enough how awesome this tool is. It is extremely convenient to use. You have amazing integration with CloudFormation. You can use your own favorite language like Python, C#, Java, and TypeScript. Everything is provided by AWS, so no third-party solutions. I like that. And I personally use this tool to manage all of my infrastructures in AWS. Okay, so let's go with the AWS CDK tool. Here you can see how you create resources with it. I use Python, and And for this instance, this is how you create a custom master key to encrypt and decrypt resources. So yeah, our step one is to create a custom master key for database and other encryptions. Once we've done that, now we create two security groups. The left one is for the database and is called DB security group, and the right one is for the resource that needs to access the database, conveniently named con security group or connection security group. Well, you can actually name them however you want. I just chose for convenience purposes. Notice how we have chained those security groups together by saying that the database security group's peer is another security group. So you see that red line, and on the left you see peer equals con security group. Basically what that means, and listen to me carefully, that means that any resource that has this DB security group applied to it will only allow traffic from or to another resource that has a con security group applied to it. In other words, if I create a resource and I don't apply the con security group to it, I will not be able to reach the database. I hope that makes sense. And well, for the third step, I think this, yeah, this one. Okay, so we have done with the security groups, and now let's create the database itself. Just for fun, I will create a serverless Aurora MySQL compatible database. Yes, the database is going to be completely serverless and autoscale depending on traffic. Notice how I have applied a DB security group to it. As you can see down below, like DB security group. Also, I would like you to notice how easy it is to create a database by following best and most secure practices with AWS CDK. Just a few lines of code. Next, I have left the greatest part for last, and this is the magical part. It is called enabling dynamic database passwords, or in other words, enabling database password rotation. What that means is in AWS, you have a fully managed service that is attached to your database, and it changes its password every 30 days or so. I want to mention that this database secret class, where you can see in the screen, is not provided by AWS CDK natively. It is rather provided by iDenfy, which has created an AWS CDK-based library specifically designed to enable password rotation. It is a public and open source project. You can simply include it in your existing AWS CDK projects. Anyone can download it, modify it, and, well, preferably do pull requests to increase library's functionality. Everyone is welcome. So, for demo purposes, I have created a CloudFormation project, and I have created this infrastructure to materialize what we were talking about. So, we have an infrastructure which is fully managed by CloudFormation. Let's talk about icons first. So the blue icon is RDS, and it stands for Relational Database Service. So we have our database here. On the right, we have KMS CMK, which stands for Key Management Systems Custom Master Key. And you use this resource to encrypt other resources, for example, RDS. or a secret. Down below, we have a secrets manager where your secrets and most specifically database credentials are stored. And on the top side, where it says Lambda, we have a computing resource. It doesn't have to be Lambda. It can be a virtual machine, which in AWS words is EC2. You can have a running Docker container. It doesn't matter. So inside this infrastructure, we have an RDS DB instance that is encrypted with custom master key. It also has a database security group applied to it, as you remember previously, which is called DB security group. Also, we have a secret in secrets manager here down below that rotates the database's password. The secret is also encrypted with custom master key. For demo purposes, we have an instance, which can be Lambda, EC2, or any other, which has a connection security group applied to it. Remember, it is very important if we want to reach the database. Also, it has access to the custom master key in order to decrypt the database and the secret. Also, it has to have access to the secret itself in Secrets Manager to retrieve the secret password. So, in order to successfully establish a connection to a database, you need three things: an appropriate security group, an access to a custom master key, and an access to a Secrets Manager secret where the password is stored. Okay, so enough of the talking. It is the demo part. Before I start showing the demo, I will show you where I have retrieved the secret rotation library. It is stored in iDenfy GitHub public repository. All of these repositories, all of these projects are open sourced. Everyone can download, everyone can use them or modify them. So for example, my favorite, where is it? Yeah, this one. My favorite project is AWS CI/CD Lambda, where with AWS CDK, you can just simply import this library, add few configuration parts, and what at the end of the day, what you'll get is a full out-of-the-box Lambda solution with continuous integration and continuous delivery, which will include code commits, code build, code deploy, code pipeline, the Lambda itself, SMS notifications, and many other things that you don't have to worry about. Everything is thought for you. So I have used the secret rotation, which is here, AWS Secret CDK, and there are many more that you can try out. Okay. One more thing, if anyone is interested how the CDK, the AWS CDK project itself looks like, so it is kind of very simple. You have your entry point, and here we are defining a VPC, which stands for Virtual Private Cloud. We are creating a custom master key. We are creating two security groups, as you can remember, one for the database and one for the resource that wants to access the database. We are creating the database itself. We are creating this secret rotation provided by iDenfy, and then we are creating some test instance so we can log in and test the access to the database. So if we would just go to any file, let's say we go to the database. As you can see, it is very similar as I showed you in PowerPoint presentation. You can just add more configuration parts to it. So yeah, this is how you define infrastructure as a code with AWS CDK package, and it is extremely convenient to use. After you have written all the code, you just simply write CDK deploy, and it will deploy all of the infrastructure for you using CloudFormation. So how does this look from AWS perspective? I have logged into AWS Management Console, and I will go straight to CloudFormation, and I will show you how it looks like from CloudFormation standpoint. So there are 2 templates, and those 2 templates have initiated all of my infrastructure. All of the resources are created by this CloudFormation tool. You see like SSH keys, the database cluster itself, various policies, metadata, and so on. I don't have to worry about them. I just need to write the Python code. Okay, we can go to RDS and check if our database is there. So I just go to DB clusters, and I see that, yes, actually, I have the database, which is actually serverless, and it is MySQL compatible. Now let's go to the most interesting part, the secret rotation. So we go to Secrets Manager, we go into here, and indeed we have one secret. We open that secret, and this is where you actually store your credentials. Note that you can restrict access to this resource. Since I am the administrator, I can do whatever I want. I can retrieve or delete or create secrets, whichever I want. However, you can restrict access to your other colleagues or even to the resources like Lambdas or EC2 instances themselves. So in order to retrieve the secret, you simply hit that button, and here you go. You have all your credentials right here. So you have the engine, username, that DB name, host, password, and so on. And yes, I am totally fine sharing this information with you for 2 reasons. There is absolutely no chance you can access this database, even though you know the password, because of all these isolated subnets, no public IPs, and security groups. So it's totally fine. And the second reason is I have enabled a rotation, which does the password rotation every 30 days, or I can do it anytime I want. So let's say after the presentation, I will just hit rotate secret, and the password will be changed. Anyways, let's try to connect to the database now. I will go to EC2, which stands for Elastic Cloud Computing, and I have created one demo instance, and I'm going to connect to it. Make it a little bit bigger. Yep, I have connected it to it. Now I'll just check, do I have MySQL? Yes, I have MySQL client. And yeah, let's try to access the database now with current credentials. So the syntax is very standard. We provide the username, we provide the host, which is not the local host, and we are going to specify that we want to specify a password, and the password is this guy. And here we go. We have successfully connected to the database. Let's give him a query, show databases. Awesome, it truly works. Okay, so let's terminate the connection to MySQL. And let's try to initiate secret rotation. So what I'm going to do now is I will press rotate secret immediately and hit rotate. As you can see, I get the green prompt that the rotation has been started. Usually it takes roughly 10 seconds to rotate the password. However, sometimes it might take longer. To test this, let's try to access the database one more time with the same password. I haven't refreshed the page, so the password is old, and I hit enter, and well, conveniently enough, it says access denied because the password has changed. What I'm gonna do is, as I'm gonna go back, I'm gonna hit the retrieve secret again, and well, as you can now see, the database, the password has changed. What I'm gonna do now is I am going to try to access the database again. I'm going to paste the new password, and voila, the new password now is in full effect. I can do queries again. So this is how you enable password rotation on your databases. Let's terminate the connection, and we're good to go. All right. So this is the finale of the demo part and the presentation itself. However, I want to make a few closing remarks. Firstly, I want to say thank you to iDenfy for making AWS CDK-based packages public, so any developer could use them. You should definitely check out iDenfy GitHub page for more AWS CDK-based packages that will definitely make your life easier. Also, I want to mention that all of the libraries seamlessly integrate to your existing AWS CDK projects, so you won't have problems with that. Secondly, this is kind of a pitch part. I'm looking for developers to join my team, so feel free to contact me. I will tell you more about the project. The project is very awesome, so write me. And thirdly, there are some things that I haven't touched in the presentation. So these things are role-based DB access, which is just another layer of the security that you can apply to your databases. So you not only have to apply security groups, but you also have to apply roles to access the database. There are VPC endpoints that actually allow you to access internal resources that are in private subnets from external sources. There is a secret retrieval latency. So every time you retrieve the secret, it will take roughly from 50 to 150 milliseconds. Well, there are obviously many other ways of storing credentials, and in my opinion, this was probably the best one. This technique also works for other databases that are managed by AWS. So, for example, DynamoDB. For custom master key, you can also enable its rotation, which just gives more of the security. And well, I haven't touched many other things that I would have liked, like the AWS CDK itself, the CloudFormation part, public, private, and isolated subnets, VPC stuff, and so on. But I think this will be for the later part. And I have done my presentation, and it's time for questions.
Laimonas, as you said, you'll take 30 minutes, so yeah, like perfect timing from your side.
I've trained. I've been training.
Yeah, that's shown. I don't know what about everybody else, but at least for me personally, it was very interesting to see and to hear what what's your approach to this topic. And I made notice of the fact that that you are open to dig deeper into some other topics, maybe in next events. We have quite a number of interesting questions, so I'll just read them out loud for everybody to hear as well. Okay. So Lucas was the first to ask even before the presentation started. So what are the best practices for connecting to databases in private subnets? For example, developers should be able to connect to a database using Management Studio. Do you have any ideas or recommendations on that?
Okay, yeah, I see the question. Well, with my current approach, there is absolutely no chance you can connect from the external source. And it is not because it doesn't have a public IP address or it's in isolated or private subnet. It is because of the security group that there is no way for you to attach to because you're not in AWS environment. So you would have to have some looser restrictions. So for example, don't use security groups, like chain security groups. And if you don't use them, well, there are then some ways of connecting it. I have mentioned something called VPC endpoints. They are one way of accessing private resources. You can, well, investigate it further. I don't think I have enough time to explain what VPC endpoints are. Also, for private resources, I make, well, what I usually do is I make public proxies. So let's say I have a private EC2 instance, then I have a public proxy instance that simply proxies all the requests to the private instance. And this is also one way of doing stuff. So I hope I have answered the question.
Yeah, I think that there's most probably some more research needed on the things that you mentioned to dig deeper, because there's a lot of options.
Yes.
Kasper is also asking, can you comment pros and cons between Vault and AWS Secrets Manager for credential management? Have you tried Vault?
Well, I personally haven't tried Vault. And am I correct that it is kind of a custom solution with custom CloudFormation template, which creates a Vault for you?
Could be. Yeah, Kasper, if you could just on the chat to maybe specify the Vault part that you're referring to, and we can get back.
If I, oh yeah, HashiCorp.
HashiCorp.
Yeah, but isn't it's like the biggest con €600 per month or something like that?
That's.
I think, yeah, I've been researching this, and it was like the ridiculous amount of money that you have to pay for that infrastructure. There are a lot of backup services surrounding this and so on, and therefore you have this ridiculous amount of money that you have to pay. I might be wrong, but if I remember correctly, yeah, this is the biggest con, and with AWS Secret, it's way different. It's just cents per month. It's nothing compared to the Vault itself.
We also have a nice question regarding the microservices from Peter. For example, a Kubernetes node, which has many microservices, each with its own database. If you create a security group for accessing each database, then you will quickly hit the maximum limit of security groups per network interface. What would you recommend to mitigate this?
Yeah, so, well, one thing, I'm not sure if the number of security groups per network interface is the hard limit. I think it is. I think it is the hard limit. You cannot ask the AWS support to increase that limit. So I think this would be one of the cases where you just cannot use that. Yeah, I don't have a really nice solution despite just not using that.
Yeah, not every solution works for every case. I guess that's normal.
Yeah, and one second. Lauras Jozulinas said that some AWS native databases support IAM authentication. That is very true, and you can use the IAM authentication, which is just another layer of security, as I've mentioned in my final presentation, that I haven't touched this topic, but it is definitely an additional security layer.
Okay, then the other question is from Vyacheslav. Is there a small downtime when rotating the passwords? For example, if a service connects to DB fraction of a second before password change, will it get disconnected? Like, do you know it from practice?
Yeah, from practice perspective, we do not experience any downtime because the rotation is very quick. So once the database once the password is changed in the database, the secrets manager immediately updates its password also. So it might be just milliseconds, like tens or maybe 20s of milliseconds. And yes, if your service happens to try to establish the connection to the database in that very, very narrow amount of time, yes, the connection would fail, obviously. And one of the things how you would mitigate this issue, you would configure your code a little bit to retry the connection a few times. But generally, if you are rotating password every 30 days, it is not very often, and the amount of time it takes is very minimal. So if you have hundreds of microservices, you can expect, I guess, just a few of the connections failed, but you should definitely retry them. Okay,
and Kaido comes up with, I guess, a very good good question on the overall idea of this approach. What kinds of risks does CMK approach mitigates? What are the scenarios that it protects from? For which specific reasons do you recommend it?
Yes, so custom master key gives you more power over controlling who gets access to the key itself, because with the default keys provided by AWS, as far as I know, you cannot control which people or which resources can access it. However, with the custom master key, you have a policy document, and in that policy document, you can specify as many rules as you need for restricting the access.
Okay, thanks. And Lauras is also has a question about what would be the use case where you use passwords for DynamoDB instead of IAM role? Do you have any ideas on that?
Yeah, so with DynamoDB, I think you should definitely use the IAM role because it's built very seamlessly to it, but as far as I know, you can for the security you can use both password and IAM role, if I'm not mistaken. If I am, and you need to choose between the password and IAM role, well, you need to think what is more secure for your infrastructure. I think that changing passwords, rotating passwords every some time is ridiculously secure, because actually no one in the company knows what the current password of the database is. And well, maybe with IAM roles, you can do some misconfiguration, which is always possible. And that is why you need extra layers of security, because if one layer is misconfigured, other layers will save you.
And the last question we have, at least at the moment, before we start with Mikk's presentation, Kaido says, thank you for the rotation code. What kind of additional resources besides iDenfy do you recommend for CDK and Python?
Okay, I'll just, what kind of additional resources besides iDenfy do you recommend for CDK Python? Okay, so there is the API documentation itself, which is quite helpful. However, for all the possible configurations of the resource, you simply go to CloudFormation documentation, and it is one-to-one relation to resources that you define in your code and the resources that are documented in the CloudFormation documentation. So, for example, when you create a, let's say, custom master key, all of the configuration parts are documented for you in the CloudFormation documentation.
Great. So that's all the questions we have for now. Thank you very much, Laimonas, for stepping in and presenting this. I see that you definitely spent some time on preparing for the demo and the slides. So it's I guess it was beneficial to a lot of people that were listening. And now we can move on to the next presentation. Mikk, are you ready to take over from Laimonas?
Yes, I guess so. Warm welcomes to everyone. So I am Mikk Lellsaar, and I'm working for Posti. So just a second, I will share also the presentation right away with you. My presentation will not be so technical, as my position also in Posti is called technical manager. So therefore, I do not do so much. I do not do so much hands-on stuff in AWS, but still, I hope you will find my presentation interesting. And yeah, if you have any questions, then type them in the box, and we will take them afterwards. So, yeah, like said, I'm working for Posti Group, which is Finnish company, Finnish government postal company, and just to give you some background before going into the AWS topics, is that yeah, we are operating in 10 countries, including in Baltic countries. In Baltic countries, our company or our brand is probably known as Itella. Additionally, in the Baltic countries, then we also present in Russia, Germany, Switzerland, and also in Scandinavia. We have more than 20,000 employees and lot of business customers. And as you can see, also a little information also about the infrastructure. is that basically what does it mean that we have more than 2,100 service points? This means like we have postal offices. Additionally, the postal offices, we have also partners who are also helping to provide postal services for our customers, for citizens, and also for our business customers. So, for example, our service points are also here in Estonia. I think it is known as Erkioski. Also in Finland, I'm not sure in other Baltic countries if there are some this kind of brand is existing there. But basically, what this all means that we have to connect all those different service points actually into the one Posti network, and this is definitely a big challenge for us. And of course, this also means that there is so much different service points, and we have not global, but let's say regional service what we provide. This also has driven us towards using public clouds as much as possible. Daily, we are sending, let's say, average is 8 million parcels currently. Or in current situation, of course, the parcel sending has been boosting. So if there are some companies where this current situation with this virus is boosting the business, then definitely one of those companies are parcel, or one of those business areas are basically parcel sending areas, because our parcel deliveries are currently at the same level as in Christmas times. So therefore, we have currently a lot of work with parcel deliveries, and our logistic centers are overwhelmed of different packages. Also some commercials as well. So we try to be as environment friendly as possible. And before going into the AWS topics, one more commercial slide, what kind of services we are actually providing. So additionally to the sending the parcels, additionally the postal services, so every day we have to take newspapers and letters to our customers in Finland. And then we have also e-commerce platforms where we are like let's say small competitors to Amazon. Additionally to those services, we also do the warehousing, shipping, also shipping the food if it is ordered by our customers, and also providing logistical services. So maybe as one fun fact is that in Russia, of course, in Russia there is a lot of logistical companies, other logistical companies as well. But fun fact is that if in Russia, if you want to have let's say, if you want to be sure that your parcel is going to be delivered and it will be received, then you usually use our services or some Posti services there. So therefore, our services, they are considered quite high quality. And additionally to that, of course, we have now gathered, we have a lot of valuable data. So based on this data, we are creating different software solutions and also providing different software solutions for the business partners. But yeah, this was just commercials about the Soome Posti, or about the Itella, as you know it here in Baltic region. Now more to the business, or more to the topic what we have today. Regarding to the AWS, we have been AWS users already very long time. So our company has the cloud first strategy implemented already 3-4 years ago, and this means basically that all the new developments are done in cloud. So we are not doing any developments on premise. But as we are very old company, then of course we have still, let's say, data centers and servers running somewhere, and so we have a lot of legacy stuff. So therefore, therefore, we have also decided that we will have a multi-cloud approach, which currently means that we are using AWS, and also we are using quite heavily Azure cloud, and additionally then we have our own, let's say, those are not our own data centers, but we have a partner who is providing the data center services. So Tieto is basically providing also the data center for us, and we are using also additionally to AWS and Azure, we are also using Tieto provided cloud as well, which is called One Cloud. But of course, this is not yet in this maturity level as AWS and Azure. Like said, we have a lot of applications. In total, we have 200 applications, which are then dealing different part of this services which we are providing. A lot of them still currently, most of them are in data center. And also those applications are basically developed by different teams, and we have also in-house development teams, but those in-house team is not capable to deal with all those applications. Therefore, we have a multi-vendor environment as well. So we are like really big corporation, and therefore currently struggling a lot with doing let's say new developments, and also with actually enabling our cloud first strategy, or forcing our cloud first strategy. Because if you have so much development teams, this means that also those development teams capabilities to deal with cloud technology also vary a lot, and you cannot just jump into the cloud at once. But like I said, we have been using AWS since 2014. This means like we have been using this already 6 years, and of course cloud develops all the time, and this of course means that this environment which we built in 2014 is now outdated. So it is not anymore suitable for our needs. It is not suitable for modern, let's say, development tools and modern development ways of working. So therefore, last year we started the project to build a new AWS environment for ourselves. And yeah, just one more thing regarding to our historical background is that our current environment, which our old environment is basically a single account environment, which means like we are currently running all our production, testing, development loads in one account, which of course is not according to the best practices. So this was also one of the big reasons why we are needing a new AWS environment. So we started this project last year. First of all, we made list of requirements which are definitely needed if we are starting to build a new AWS environment. Here I listed, let's say, some of the things, but this list is of course this is not complete list. So this is just a list of the, let's say, some of the things what I thought that could be stressed out. So for example, we decided that that access to the new environment will be not done through IAM. So we are using basically our enterprise AD to have access there, Azure AD, and no IAM users are not allowed at all to access our AWS environment. Yeah, of course, like you said, Posti is big corporation, which means like you cannot let's say you cannot just go somewhere and tell that I need a new AWS account or I need support in this ICT area. This means instead to be sure that every request is met. We have a ticketing system and of course separate service desk. And of course, if you have this kind of service desk and ticketing system, then it makes things quite slow. If you are thinking about AWS, like for example, what I mean here is that usually if you need AWS account, you just go there in AWS, you do some clicks and you will have an account ready. So, but in corporational world, this is not how the ways are working. There you have service desk, there you have tickets, there you have basically someone in service desk is forwarding the ticket to the next one, and which means usually this account creation takes a pretty long time. So we internally decided that we will make this as a requirement that all the new accounts has to be created in 2 days. So currently, to be honest, we are still a little bit far away from here, but this is our aim. Also all the resources, AWS resources here, I mean, then has to be recorded in our management database. So where all basically on-premise resources are recorded, and also then cloud resources are recorded. Only EU regions, AWS regions can be used. So we cannot, due to the GDPR restrictions, we can't hold or store our data outside of EU regions, which means that for our AWS environment, we just enabled Ireland region currently. Of course, now the Stockholm region is also possible, but as Ireland region is the most mature from the service perspective, so we currently enabled just this region for our workload accounts. We are centrally also collecting the logs, which means all the AWS related logs are centrally collected and sent to our central log management system. To have a secure connection to AWS, we have built a direct connect towards Ireland region, and of course to be sure that the connection is not lost, the connection is redundant. And on top of the direct connect, we are using transit gateway, which makes then communication between different accounts more easy and more convenient. And I totally support the way of thinking that you should have everything, including infra as a code. So one of our requirements was also that if we are building now a new AWS environment, then this environment has to be written in code. So you can basically redeploy it if needed, and you can basically read the code to see where are the for example mistakes or what. Basically you can read the code and to understand what has been built. And of course humans tend to make mistakes. That's why we have been trying to automate as much as possible. Of course, just automate because of automation doesn't make sense, but we are trying to automate as much as possible, and therefore, for example, all the deployments are automated, and also if we are doing some changes in our new AWS environment in Landing Zone, then this changes also happens the automated deployment. So nothing is done manually. Of course, some routing needs to be done manually or configured manually, but as much as possible, we are trying to automate. And like I said, in old days, we used to have just one account for all the environments, for the development, for the testing, for the staging, for the production. So now we are having a different approach. We have a multi-account environment where basically each project or each application has a separate account for the development, for testing, for the staging, for the production. Of course, this means in the end that we will have a lot of accounts. Like said, we have in total more than 200 applications. So if we will put all the applications to AWS, then we would end up like around 800 AWS accounts. But luckily this is not the case. But definitely in the future we will have a challenge how to manage and govern this multi-account environment. And of course, we are trying to enable developers to do as much as possible themselves in AWS. So therefore, in development environments, they will have full access if they require this. And yeah, in higher stages, then our cloud operations teams will help them to deploy the application, for example, to the production environment or to the staging environment. But in development and testing environment, developers can pretty much they have pretty much free hands, and they can do what needed. Of course, we still follow what they are doing to be sure that they are not consuming too much resources, or basically we are just checking that they are not over consuming their stuff, but otherwise they are free to do their stuff themselves. And now back to the let's say today's topic, AWS Landing Zone. So this is basically separate AWS service what we decided to use for building our new AWS environment. This service itself, it is pretty new, and what it actually is that basically this is the bunch of AWS CloudFormation scripts which you can use to build your new AWS environment. So you will take those scripts, you will modify and customize those for your needs, and then you should have a new environment. Of course, this sounds easy, but of course there is a lot of scripts, and so you have to do a lot of cleanup, and you have to read very carefully what is written in those scripts, and you have to customize the stuff as for your needs. So, for example, in our case, we took care that basically it reflects to our multi-account model. Here you can see also the architectural picture, what our multi-account looks like. So we have core account, we have basically different core accounts, then different common, not core accounts, but basically we have core accounts, then we have common accounts, and then we will have accounts for the different business units. So for example, one business unit is digital commerce unit, and common accounts are then like networking account, shared services account, security, and like said, we are collecting logs. Therefore, we have also separate account for the logging. And product which we used, our service which we used then was AWS Landing Zone. This is using, like I said already, CloudFormation templates. So we have to just store this code in our code repository, modify the CloudFormation templates there according to our needs, and then deploy it, and voila, you have your AWS environment up and running. But of course, the description what I gave you currently, it sounded very simple, but of course we have been dealing with that project already half of year, so it is not so straightforward. And in the future, in the future, if, for example, new workload accounts are created, then this can be doing via service catalog product called account vending machine. So you just start this account vending machine, add there your inputs and basically configurations, and then again deploy. Save the code repository also for this account, then deploy it, and then you will have right away automatically you will have like 4 new accounts for the production, development, testing, and staging. And yeah, like said, one of the main reasons why we started to why we built new AWS environment was to meet the security requirements, because yeah, having all the things in one account, this is really really dangerous. And also another thing is like now we have also with this new solution, we build it that way that we have also this disaster recovery possibility. Therefore, we have a separate backup account where we back up basically all the data from different workload accounts. And for example, if something happens with and this backup account is standing separate from this AWS Landing Zone environment. So if something happens with the AWS Landing Zone environment, then we still have our data available in backup account, and you can use this account for restoring the applications, for example, or restoring your workloads. And yeah, another very important thing what we have achieved is also that before we had account created 2014. This means that a lot of things had been happening there, which means like a lot of cleaning actually was needed. So if we created this new environment, then we will have like clean sheet, and we can basically, if we start migrate from the old account to the new account, then we can take care of that the proper cleaning of this old outdated stuff has been taken care of. And yeah, this is let's say this is briefly about all this AWS Landing Zone. I also listed maybe some learnings what we had from this project. And what I just would like to stress here is that, or before going to the learnings, what I like to stress here is that that in case of Posti, we are a big corporation. So this means like we don't do too much things ourselves. We usually outsource. So for this AWS Landing Zone, also we used external resources to help and build this. And also in the end, also in this new AWS environment, there will be a lot of externals working. This is not only for the Posti workers, but there will be also external developers, and there will be. This means like the environment itself has to be understandable and easily accessible also to the external parties, which is a little bit complicated because Posti has really complex network, and this complex network also means like the restrictions are quite harsh there, and we are also dealing with lot of very sensitive data, which again requires extra measures. So therefore building this new AWS environment, it was for us it has been a little bit more complex and maybe challenging than it usually is. But yeah, what were the learnings from this project was that basically if you want to build a new AWS environment, then take care that you have a experienced and skilled partner for this, because yourself, of course, we have AWS knowledge in-house, but still it is always better to have a partner beside you who can guide you through, because still our Posti business is not the IT. Posti business is postal services and logistics. So therefore, to have actually, let's say, environment which is fulfilling the business needs, it is better to have also the professional partner for this. We have been struggling also with finding this professional partner, but now hopefully it is there. We have switched this 2 times, but now hopefully it is there, and we can already see that now that basically things are improving, and we are getting closer and closer to the environment what we actually need. Also, choose the starting point wisely. What I mean by this here was that those requirements which I shared with you, for example, that we decided that the IAM user shouldn't be there. We decided that there is no, you cannot connect to the internet from AWS resources, so everything has to go through a separate proxy which has created for that. All those kind of requirements have to be listed and have to be. It is better if you also walk through those requirements with your partner to understand what is actually achievable in AWS and what is actually maybe not needed or not wise to use. So therefore, let's say, prepare yourself well, and then you will, in the end, you will probably have a better AWS environment for your needs. Also, one thing what during that project we have been missing is Cloud Center of Excellence. So like said, we have partner, but also those partners, or if you have the partner who is building together with you this AWS environment, even then it would be good if he has, let's say, counterparty with whom he can discuss those different capabilities what AWS provides. So in case of Posti, we have more than 200 applications, and of course there is not possible to meet all those application needs in this AWS new environment. But for example, if you have partner who is suggesting the proper AWS environment, and then you have also in-house Cloud Center of Excellence who actually also can guide those applications towards cloudifying their application, then this is something what can create good value for the organization itself, and also smooth the process to migrate applications, old legacy applications, to the cloud. And of course, nowadays everyone is talking about DevOps, and so it is in Posti as well. So we have had several agile courses. We have had several different workshops where we are trying to get leaner and leaner. But on the other hand, you still have those big corporation policies, like you have to have this ticketing system, and you have to have the service desk. You shouldn't communicate straight to the guys who are doing stuff in the cloud, but all the tickets has to flow through the service desk. All those things are actually something which are kind of stopping this cloud adoption, and also putting brakes in creating, for example, new cloud environment as well. So therefore, here my suggestion is, or my learning is, that basically you have to convince everyone that this is not you are that basically cloud is not something specific, but cloud is just part of the way moving towards the DevOps, the agile culture. Because in the end, if you are not agile, or nowadays if you are not deploying stuff fastly, then this means like you are losing business. So yeah, those were basically the learnings what I had. This lecture was, or not lecture, but this talk wasn't so technical like the previous one. So I think we got good balance here. But yeah, this is the way. This is what we are currently doing and trying to achieve, and we are definitely appreciate what the AWS provides, and trying to migrate more and more our resources to AWS.
Thanks, Mikk. Yeah, as you said, I think that was a very good balance on from deeper technical perspective to maybe wider organization perspective on how we should manage all the stuff, especially once you're as big as Posti. We have a few questions I see, but just before going through them, I would maybe from my side also ask a few things, because, well, frankly, I don't know any company using Landing Zone in the Baltics at the moment. Yeah, maybe I just haven't heard of it, but it's still, like you mentioned, rather a new service and an interesting one. Do you understand that you more or less finished the project, and if yes, how much did it take you from the beginning to the start to build all of that, because it seems rather really complex?
Yeah, it has been complex project, and yeah, Landing Zone, I think it was published, I think, last year, if I'm not mistaken, and we decided last summer in August that okay, let's use the AWS Landing Zone for building our environment. To be honest, I don't know also here in Scandinavia region or in Baltic region someone who is using the AWS Landing Zone for building new environment. We had to make decision, like our previous partner suggested us to use AWS Control Tower to start building this multi-account AWS new environment, but Control Tower wasn't suitable for us. This is also Control Tower this is also AWS managed service, and this is also a service which provides you multi-account environment. But the case with the Control Tower is that this is more suitable, not so mature clients as Posti was already. Posti has been using AWS already a long time, so we had our needs, or our special needs. Control Tower is suitable for the let's say greenfield, or if you start from zero, you don't have anything in AWS, so then Control Tower would be easy way to deploy your new AWS environment. But this didn't suit for you. And another thing also what Landing Zone provides is that you have all your infrastructure as a code. So this was one thing which also drive us towards the Landing Zone. But yeah, it has been struggle. So we have been doing this now more than half a year. We are almost there, but still we haven't put any production workloads there.
Yeah, okay. Hopefully it will be successful and will be close soon. Just last question from my side. How many AWS accounts do you have in plans, or do you have there, the number that I've seen in the slides, or even more, just to understand the scope and the size?
Yeah, I think currently it is a little bit more than 10, but of course, if more and more are appearing there, if finally we have finalized the environment, then more and more applications are coming. And like said, like basically every application which will come to this new AWS environment, there will be right away 4 new accounts for the production environment, for the testing, for the development and staging.
That sounds like an
Great.
overkill.
We have a few. We have a few questions from the audience. Roman is asking, you mentioned a separate proxy. Does that mean kind of app mesh, like AWS app mesh or Istio? What are you using for that?
No, we are using egress proxy. So basically, if you want to connect to the internet, then all the connections are going through this proxy. So we have basically, again, we have a deployed 4 different proxies. So basically we have this separate network account, and there is 4 different proxies for the staging, developing, testing, and production. And we're using those proxies to then connect to the internet if needed.
Okay, and I saw a remark from Peter, I guess, on the one of the first slides you had. Would perhaps the AWS single sign-on service replace the need for the time-consuming help desk process? How do you see that? Because I think that's one of the parts of Landing Zone, the single sign-on.
Yeah, it is, but mainly, like, for example, service desk, you don't need to access. You don't need service desk to access for the AWS account, but for example, if you want accounts to be created, then you have to create a ticket to the service desk, and then service desk forwards this ticket to the cloud team or our cloud partner, then who creates with this account vending machine creates the 4 new accounts. If those accounts are created, then basically service desk also add you to the correct AD group, and you will have the access there. And afterwards, it is of course easy. Then you don't have to. You can access as needed and anytime. So then you don't have to turn towards the service desk. But even like we would like to get rid of this or automate the beginning part as well. So account creation also more, just to minimize the service desk part there. I hope I responded to the question.
Yeah, I think so. And that's all the questions we have from the audience at the moment. And I see that we're like also perfectly on the scheduled time. Maybe that will be also a nice tradition for the next events. I would like, I guess, from all of the audience, say big thanks to Mikk and then Laimonas. Thank you very much for your courage and time spent on these presentations and sharing the knowledge. And for everybody who was listening, I hope you had a good time, learned some new things. I was happy to see that we even had some discussions or answers coming from the audience itself. And before we end up, Mikk, are you open for one more question? Let's see, we have one more coming from multi-cloud approach, so that should be interesting to a lot of people. Mm-hmm. What was the main reason to go with the multi-cloud approach? Do you co-house the best cloud suited for a specific workload on a case-by-case basis? Like, yeah, I guess it's a common question. Like, how do you choose? If you have multi-cloud,
which cloud to use?
Where? What
basically, it was multi-cloud decision was made to a little bit avoid the vendor lock-in, although anyway, it would be very difficult to migrate the AWS stuff to Azure or opposite way as well. But also, we are doing the division based on basically application functionality a little bit. So all the let's say, data-driven applications, they are usually hosted in Azure, as we have BI tools there, and we are using Azure Data Lake. So therefore, all the data-driven applications, we are usually hosting and building them in Azure. The applications which are customer facing, they are usually in AWS. But yeah, it little bit depends. Usually, it depends also on application architect. So how he decides which technology he prefers. But of course, from my side, I usually try to force them towards AWS.
Yeah, that's a very good approach, I think. So yeah, so thanks a lot for the last question and the last answer. I guess that's it for us today. Like I mentioned before we close, we are looking for speakers like Laimonas and Mikk for the next event, for the next community event. Hopefully their lead will encourage some more people to step forward and share their experience or solutions that they've built by themselves. So at the end, I'll just leave my contact information, and if you are the one that would like to speak and share something, just reach out and we'll talk a bit more about it. And for everybody else, thanks for your time and have a nice evening.
Bye, guys.
Thank you. Bye-bye.